Hi, I'm Adrian and welcome to Jack of Trades. This video is a bonus part of our Laravel 8 and Livewire series, where we talk about how we can make a simple content management system with Laravel 8 and Livewire. Working with WebSockets is not necessarily needed when trying to build a simple content management system, but in this modern era, doing simple CRUD functionality is nearly not enough because most users wanted a real-time feature for some parts of your applications. So, I honestly think that you should also become aware of these real-time technologies that help you build a real-time feature for your applications. That is why I added these kinds of videos here in our Laravel 8 and Livewire series. So, in this video, we will reuse what we had done from the last video where we built a push notification feature without using Pusher. Instead, we have created the push notification feature using Node.js and WebSockets. This time, we will build a simple chat application and store all the messages in our database. We're going to make the users talk through private messages by assigning them in a specific room ID for each of their conversations. And without further ado, let's jump right into it. But before we jump into the code for our chat application, we still need to prepare a couple of things. First, we need to create a Livewire component that will serve as our chat component. Second, we will need to create a model and a migration file for our messages because we will store all our users' messages through the chat. So let's go ahead and do that. Next, let's go inside our WebSocket folder and install MySQL and UniqId packages. Since we are using MySQL as our database for our Node.js application, we will need the MySQL node package to easily connect to the MySQL database and do some simple queries. We also need the UniqId node package to generate unique strings that we will use to identify each connection instance for each client application that connects to our Node.js WebSocket server. Remember that each client application we refer to can also be a mobile application connecting to our WebSocket server. In our case, the client application is our Laravel app, and each connection instance is created when we open our Laravel app in a specific web browser. The unique ID that we will create later will serve as our means to identify what client application connects to our WebSocket server. Of course, we know that our Laravel app is the only client application for now that accesses our WebSocket server. But even with one client application, we will need to create another connection instance if the user is opening our Laravel app on a different browser. So, let's open up our migration file and add the columns that we will need to store the right kind of information for our messages. Luckily, we will only need a room ID, a user ID, and a message column since this is just a simple chat application. After that, let's run PHP artisan migrate to create our database table. We will also need to add the fillable properties for our model so that we will be able to save the message in our database table when we use the model class later. Now, let's go ahead and create the user interface for our chat application. To make it quick, I have a CSS style for the chat component, which I just copied from the w3schools.com. We will paste the CSS code to the chat.css file shortly. Don't worry, I provide you the link to the CSS styles in the description below so you can easily copy and paste them while you follow along in this video. I also need to make this client socket function separate into a different JavaScript file to make our code a little cleaner. And again, we need this Socket.js file for our chat front-end JavaScript code later. Now, I'm going to include the Socket.js file right here. And let's paste in the CSS code right here just to save time. In this part, we're just building the HTML code user interface for our chat component, so I suggest you just follow along as we write the code. Now that we have our HTML code for the chat component's user interface, let's add in the CSS for our chat component as well as the Livewire chat component inside our app.blade.php. So now, if we open up our Laravel app in the browser and reload, we can see our chat box on the lower screen right. Remember that you can create your own style for the chat box. We could also have done this with Tailwind CSS, but we did it this way to save time. Now, let's work out the chat pop-up visibility. In this case, we will create two functions that we will call from the front end to control the chat pop-up visibility. In the show chat pop-up function, we will set the chat pop-up visibility variable to true, and in the close chat pop-up function, we will set the chat pop-up visibility variable to false. This will serve as our indication to dynamically hide and show the chat pop-up box when clicking the corresponding buttons. This is a very straightforward Livewire firing of events, so just follow along. To make this work, we will add a wire click for each button. This is going to work when we wrap the chat box in an if-else statement like so. There is another problem. When we try to go to another page, the chat box will go back to a closed state even if we open it. We need to have something somehow to retain its state when we try to navigate our application's different pages. And to solve that, we need the Laravel cookie. We will save the chat pop-up visibility inside a cookie variable. This is pretty straightforward. When the show chat pop-up is triggered, we will set the cookie called chat pop-up show to string true for 60 minutes. Thus, we also make the same approach for the close chat pop-up function respectively, except we make the opposite. We needed to have an initial state for our chat pop-up's visibility, and we will add the logic for that to the mount function. Remember that the mount function is the first function to run every time we load a Livewire component. So we will put our logic in this function. So with this technique, no matter how many times we navigate to different pages of our application, we will be able to save the state of the chat pop-up's visibility. And now, for the main event, let's build the primary logic for our simple chat application. The first thing that we want to do here is wire model this text area to the message variable coming from our backend. And the second thing is we put the key down enter so that we can send the message through our chat box when we press the enter key. We all know we cannot magically send the message to the other user from the other end, so we need to create the logic for this one. Therefore, our approach is we're just saving the message directly to our messages database table along with the room ID and the user ID. So let's go ahead and do that. First, let us simulate what happens when we press the enter key. We also want to make sure if something really happens when we press the enter key through our chat box. Great, now that we see that it's working, let's go ahead and save the message directly to our database table. We also need the information of the default room ID for our currently logged in user. But in this case, to make it simpler, we will just assign these users to a static room ID. I plan that the user named Billy and Adrian will be assigned to room ID number 1 and then Richard and John will be appointed to room ID number 2. Ideally, in a real-world application, we usually see that when messaging another user in a specific application, we see a feature that allows us to connect with that particular user. For example, on Facebook or LinkedIn, we visit another user's profile, and in that user's profile, we often see a button labeled as message, and when we click that button message, we will be able to send messages to that specific user privately. When that happens, the application will create a unique room ID or identifier that you will share with that particular user behind the scenes. I'm sure there are many security measures besides that, but at the basic level, the concept is pretty close to similar. So that is the kind of approach we will take here. But the difference is we're just going to assign the users to these static room IDs. Now then, let's create the JavaScript for the front end that will handle the connection to the WebSocket server. To save us time, I will copy some helper functions we will be using for the chat JavaScript script. Don't worry, I will also provide you the code snippets for these. Just go to the link in the description below. To give a bit of explanation, well, the keep chat box focus at bottom function will automatically scroll when the text inside the chat box gets longer, and the message format function will display chat messages in the format that I desired. You can also make your own format if you wish to. The main focus here is to be able to send messages to the WebSocket server. If you have not watched the previous video, I suggest that you watch that first before this, so it gets more manageable to understand what we are talking about here. As you can see, we are initializing another client socket connection for our chat application. This time, we will connect to port 3281. The 3281 port is not yet defined since we have not created the chat server yet. So in the meantime, let's prepare the things that we need to send a message to the chat server. It's just going to be the same as the previous video. The only main difference is we are creating a chat feature this time. Let's just console that log to see if the chat WebSocket server connection is open. If you can remember, this function right here will receive the messages sent from the server. Now, let's create our chat server. Of course, the code for this will be pretty much similar to our event notification server. So to make it quick, we will copy the content of the event notification server.js and make some adjustments to it as we build our chat feature logic. We will remove some parts of the code that we won't need for this. Before we forget, let's add the chat WebSocket script to the app.play.php so we can include it in our application. Let us now continue the logic for our send message function from Livewire component backend script. Remember that we have to save the user ID in the message first, so that every time a logged in user uses the chat, the messages will be saved into our database table. After saving the message, we will dispatch a browser event that will send a message to our chat server. This approach will make the chat server be notified that we are sending a message and we need the chat server to do something about it. So, we will create the event listener from the front end to handle this for us. We will also send the room ID and the user ID to know what messages the chat server should broadcast. Of course, the chat server will query from the database and broadcast the messages it retrieved to the connected clients that belong to the same chat room. Now, let's run the chat server and see if this works as expected. When we send a message to the chat server, it's also crucial to let the chat server know what message we are sending to it. So here, we are adding a custom property type with a value of chat message. Note that you can make this up. I just needed some identifiable flag that makes it easier for me to identify if the messages that the chat server receives are indeed a chat message. So here, in the chat server file, I can make an if-else statement and check if the message I receive here is indeed a chat message. As you can see, we are able to console.log the information that we sent to the chat. That only means that we can now proceed to add the logic for our chat feature. So let's go ahead and create a function that we will call retrieve latest chat message. This function will include an SQL statement that retrieves the latest chat message based on the room ID that was sent to the WebSocket server. To be able to use and generate a unique ID, we should first initialize the unique ID module like so. And to connect to the MySQL database, we should initialize a MySQL module that we just downloaded and set up the config. Now that we are ready, let's write the remaining code so that we will be able to run the query and actually send the latest message that we have retrieved from the database to all the connected client application that shares the same room ID. Before anything else, we also need the room ID and the user ID's information once we open up a connection to the WebSocket server. This time, we need to add a different flag from the chat message. Before anything else, we also need the information of the room ID and the user ID once we initialize an open connection between our client application and the WebSocket server. This time, we need to add a different flag for the type so that we will be able to distinguish it on the WebSocket server that we open a chat connection and we're not sending a chat message yet. So that is why I flagged the message as type info. We need the room ID and the user ID before we could send a message through the chat. To explain it, every time a client application connects to the WebSocket server, there is a unique connection instance that persists. To identify this persistent connection instance, we needed to store this information as an object inside an array. In our demo, we have an array variable called clients, and this clients variable will be the storage for each connection instance. For each connection instance, we need to have the information of the connection ID, the room ID, the user ID, and the connection instance itself. To make the messages only available to those who share the same room ID, we have to match them in our if-else statement. And then send the message through each client application connection instance. And this part will receive the message that is being sent to us by the WebSocket server. Of course, this message will contain the latest record from our database table. Okay, let's test out our code and see if it works. Wow, that is amazing. Okay, so we still have another problem here. As you can see, we can't see the previous messages that the other user sent to us every time we reload the page. So, let's go ahead and create the logic for that. It is also crucial to wire ignore the message box so that Livewire doesn't replace this element when it makes a server request. Now, let's write the function to load our chat history. Okay, let's test everything and see if the rooms we created for these users allow the users to message the other user through private messages directly. As you can see, if we try to close the chat and then open it again, all our messages are gone. Let's go ahead and add another simple logic for this problem. So I hope you enjoyed this video and learned something from it. Since we are done with these bonus videos that talk about real-time features for our Laravel applications, I will let Billy do the voiceovers for the next videos. So if you enjoyed this video, give it a thumbs up, comment, like, share, and subscribe, and hit that notification bell so you'll get notified whenever a new video is up. Stay tuned and see you in the next video.